One of the polar representations of a point A is 5 and 120 degrees. Write down all of the polar representations r and theta such that theta is between minus 360 degrees and 360 degrees. In this question, we want to study the different representations of a single point in polar coordinates. As we know, there are many polar coordinates for representing the same point. Before I start solving the question, I would like to explain a subtle point about polar coordinates. Let's consider this point, 1 and 45 degrees, for example. Here is a sketch of where the point is located. The angle is 45 degrees and the distance of the point from the center is 1. Now let's consider the mirror image of point A with respect to the center of the coordinate system. This is going to be a point, I call it A prime, in the third quadrant because A was in the first quadrant. To write down the coordinates of point A prime in polar form, there are two ways we can imagine how to get from A to A prime. One way is to think that if we rotate OA by 180 degrees, we would get OA prime. If we think of OA prime in this way, then the coordinates of A prime would be 1, which would be the distance of A prime from the center, and 45 degrees plus 180 degrees, which is 225 degrees. So one way to represent A prime is 1 and 225 degrees. Another way that we can get A prime from A is to reflect the vector OA through the center of the coordinate system to get O prime. In other words, we can think of OA prime as OA flipped through the center. If we think of OA prime in this way, then we can show the point A prime as minus 1 because it is flipped through the origin with the angle of 45 degrees still. So we do not rotate the vector OA, therefore we do not change the angle, but we flip OA through the center of the coordinate system to get OA prime. That's why we would have to flip the length, which is 1, to minus 1, which is the length of OA prime. Now let's look at the question that we are considering in this problem. The point, let's call it A, is given by 5 and 120 degrees. Here is a sketch of the point. This angle is 120 degrees and the length of this vector is 5. We can add 180 degrees to 120 degrees. We would get 120 plus 180 for the angle. But then that would give us a vector which is in the fourth quadrant. We flip that to go back to the second quadrant by multiplying the 5 into a negative 1. Therefore, another way of representing A would be minus 5 and 120 degrees plus 180 degrees. In other words, minus 5 and 300 degrees. This is acceptable for us because the angle is still between minus 360 degrees and 360 degrees. If I add another 180 degrees, the angle would go beyond 360 degrees. So stop adding 180 degrees to this angle. Let's now go back to the original point, which was A, 5 and 120 degrees. This time subtract 180 degrees from 120 degrees. You would have 120 degrees minus 180 degrees for the angle. But if you look at the sketch, you would see that 120 degrees minus 180 degrees will end up the fourth quadrant again. Therefore, you multiply the length by a minus in order to flip the resulting vector back into the second quadrant. This would be yet another representation of point A with the angle between minus 360 degrees and 360 degrees. In fact, the angle is minus 60 degrees and the length minus 5. We can continue by subtracting 180 degrees from minus 60 degrees. We would get minus 60 degrees minus 180 degrees. This would result in a vector which is in the second quadrant. We do not need to change the sign from 5. Therefore, we get yet another representation for point A. That is minus 240 degrees and 5 for point A. If we subtract another 180 degrees, we will be out of the domain that we are allowed. The angle we get will be less than negative 360 degrees. Therefore, we found 3 other representations of point A with the characteristic of the angle being between negative 360 degrees and 360 degrees.